Okay, so in section 2.1, we're going to be talking about how to construct a frequency distribution, and that just means how do we put data into classes. And then we're going to talk about 3 different graphs that we can construct from that frequency distribution. So we're starting here with just an example of what a frequency distribution is and what it looks like. And like I said, all it is a table that groups data values into classes. All right, so the classes that you're seeing over here, instead of looking at each individual temperature, the first class groups all temperatures together that are between 20 and 30 degrees. The second class groups all temperatures together that are between 31 and 41 degrees, and so on. And the frequency over here, frequency is just another word for a count. Right, this is telling me the number of data values, or in this case, the number of temperatures that fell between the limits of each class. So again, the way I read this, a frequency of 19 tells me 19 of the temperatures in this data set were between 20 and 30 degrees. 43 of the temperatures were between 31 and 41 degrees. Now, I don't know exactly what the temperatures are anymore, but I know there were 43 of them that fell within that range of 31 to 41 degrees. Okay, so that's first and foremost, is just making sure that you can read and interpret a frequency distribution correctly. Now, some terms that you want to be familiar with. I used the term class limits just a minute ago. That's how the classes are defined. Each class is defined by a lower class limit. That's what you're seeing over here. And the lower class limit tells you the smallest number or the smallest data value that can belong to a particular class. And then each class also has an upper class limit, kind of giving you the cutoff point on the other side, which is referred to as the upper class limits. And again, these are the values that define each class. These are the values that tell me what temperatures can be a part of each class. The first class has a lower limit of 20. So no temperatures below 20 degrees can be counted in that first class. The first class has an upper limit of 30, so no temperatures above 30 can be counted within that first class. Now, another really important term that you're going to hear referenced here, and you're going to want to be able to identify it, is the width of a given class. Now, as it sounds, the width does define the size of the class, right? But you want to be careful in making sure that you determine this class width correctly. If I'm counting any temperatures that are between 20 and 30 degrees for the first class, right? Logically, right, you look at that and you think, well, the class width must be 10. But if you were to count that out, if you were to count out how many possible temperatures there are, let's do that. If we start with 20, right? 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Then you would see that this first class actually contains 11 different possible temperatures. Now, I don't want to have to count it out every single time. So the way the class width is defined is you can find it by taking the difference, but it has to be the difference between consecutive class limits. That means the difference not within one same class, but from one class to the next class. So if I were to look at the difference in the lower class limits of class 1 and class 2, right, the difference between 31 and 20, that would give me that correct class width that I just counted out, which is a width of 11. And notice I can see that if I look at any 2 consecutive limits, like for example down here. If I look at the difference between 74 and 63, same thing, class width is 11. If I look down here at the bottom, and it doesn't matter if I do this for lower or upper, as long as they're one right after the other, I'm going to see that same class width because the class width should stay the same for every class in a frequency distribution. All right, so again, first and foremost, make sure you can read and interpret the frequency distribution, right? Classes of data, and the frequency says how many data values were in each class. The limits, lower and upper, tell me what values can belong to a class. They define the class. The width is a difference between consecutive class limits. And again, what we're talking about here is the difference from one class to the next class in terms of its lower or its upper limits. It has to be the same type. And then the frequency again tells me a count how many of my data values fall within each class. All right, so let's stop there for right now and let's focus only on these first three terms and how we would put this information together if we had a data set and we wanted to construct our own frequency distribution. All right, and then we'll come back and talk about those other four terms in just a minute. I pulled the steps here. This is straight from your textbook, just so you'll know the steps that I'm referencing. But we're going to walk through these same steps every time we go to take a data set and construct a frequency distribution. All right, and that's exactly what I'm going to do with my first data set here. All right, so notice I have a sample data set. It contains 30 speeds for passing motorists at a checkpoint. And what I'm asked to do is construct a frequency distribution. All right, now again, based on the example that we just saw, a frequency distribution means I should be able to identify classes of data and a frequency for each class. And I am told here that my frequency distribution should have 6 different classes. You'll always be told how many classes, and that's an important part here because that plays a part in how wide, the width, that each of your classes should have. All right, so first thing I'm going to do, I'm going to look at the fact that this needs 6 classes, and I'm going to come up here and I'm going to calculate what class width I should use to construct these classes. All right, now this is a formula. I know we just defined class width as the difference between consecutive class limits, but notice we don't have the limits yet. All right, we're trying to work from a data set. So when you're working from a data set, what you're going to do is take the range of the data, that's just the maximum data value minus the minimum, and you're going to divide that by the number of classes that you need to have. And then one last thing here, really important, you will always round that width up to the next whole number. All right, so let's do that here. Our maximum data value is a speed of 72 miles per hour. Our minimum data value is a speed of 35 miles per hour. That's our range, max minus min. And then I'm going to divide this by the 6 classes that I need to have in my frequency distribution. Now, if we calculate this and we look at our exact value, right, I take 72 minus 35, divide that by 6, I'm getting a value of 6.16 repeating, essentially. So what I want to remember is for the class width, I always round it up. Now, I realize normal rounding rules would say leave it at 6. We don't do that here. For class width, we always round it up, use the next whole number. So this distribution should have a width of 7. All right, and that's our formula. It's how we're going to do it every single time. Now, once I have my class width, then I'm ready to define my classes. And the way that I will define my classes is I will always start with whatever my minimum data value is, right? In this case, my lowest speed was 35 miles per hour. And then what I'm going to do is use that class width. My class width is 7. So the definition of class width, right, says it's the difference between consecutive class limits. From this class to the next class, we should have a difference of 7. So if I take 35 and I add that class width of 7, that's going to give me 42. And it's going to tell me to start the next class at 42. Don't worry about your upper limits right now. We're only doing lower limits using the class width. And remember that class width should not change. So if I take that width of 7 and add it again, that's going to put me at 49, and that'll start the third class. Now we need 6 classes here, so we're just going to keep doing that. Use the same width of 7, add it again. That'll tell me the next class starts at 56. Keep that class width of 7, add it again. This one will start at 63. And then for our 6th and our final class, add 7 one more time, and the last class will start at 70. All right, and what we're doing here, this is defined in step number 3, right? Use the minimum data entry as your first lower limit, and then to find all the remaining lower limits, all you're doing is adding the class width to the preceding or the previous class. Now, we need upper limits too, and so all we're going to do here to find our upper limits is remember that classes should not overlap, right? If we're trying to group values, then we can't have overlap in the classes. So if we come back over here and we think about that, we just say, well, if the second class starts at 42, then the first class had to stop just short of that at 41. And I can do that all the way through. If the third class is going to start at 49, this one has to stop just short at 48. And notice, as I'm doing this, looking at the start of the next class, I'm also still maintaining that width of 7, right? The difference between 41 and 48 is the width of 7. Between 48 and 55 is the width of 7. And that should happen because remember, you can look at any consecutive limits to see that width. You will need to make sure that it happens when you look at your last upper class limit. Don't be tempted to stick a 72 in here just because that is the maximum value, because then you are changing your class width. So what you want to do for this last upper limit is take that 69, add the width of 7 just like you did on the lower side, and that will tell you that this last class should end at 76, not 72. And it is okay that that is beyond the maximum value. It's more important that you maintain the class width than end on the maximum data value. Sometimes both will happen, but if it doesn't, the most important thing is to make sure you have the same width for every one of your classes. All right, now that's our start. Once we define our classes, then the next thing that we're going to do is we're going to determine our frequency. And this is really the easy part. This is just counting. So when I look at my first class, right, it includes any values between 35 and 41. So I'm going to use my little orange color here. And I'm just going to go through and I'm going to count, right? How many values are between 35 and 41? So like 44, that's not in the first class. It's too big. But 38 is there. It's between 35 and 41, so there's 1. 41 is in that class too, include the endpoint, so there's 2. 36 would be in there, right? There's 3. And that's everything off the top row. Right? So if I just continue, I got 3 values now. I'm going to look for any more that are between 35 and 41. So this would be 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's it. Right? Again, all I did was look for values between 35 and 41. I counted them, and that gave me the frequency, which was 12. That's all I'm doing. All right, so let's go to class 2. All right, I'm going to use my green here. And now I've already marked out the ones in the first class, so I'm just going to look at the remaining, and I'm going to count the ones between 42 and 48. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 speeds are between 42 and 48 miles per hour, and so that is the frequency of my second class. All right, and then I'm just going to finish this out. So 49 to 55, looking at what's remaining, I've got 1, 2, 3, 4, right? So my frequency there would be 4. And then my last 3 classes here, if you look at the remaining values, they're only going to have 1 value in each. So from 56 to 62, I'm going to have only the 60. And then from 63 to 69, I'm going to have only the 63. Sorry guys, that's my dogs barking at somebody. And then from 70 to 76, I'm going to have only the 72. And I have now taken every value in my data set, and I have grouped it according to one of the 6 classes in my frequency distribution. All right, this is what's entailed in making a frequency distribution. Come up with classes of data using very specific steps, always the same method. And then the frequency is just the number of data values in each class. All right, now, sometimes you will be asked to expand your frequency distribution, which is what happens here, and you'll include additional values in that frequency distribution. So we've done kind of the base frequency distribution, but I am asked to add 3 other pieces of information here, and that's going to be the midpoint of each class, the relative frequency of each class, and then finally the cumulative frequency of each class. Fit that in there. All right. And this is what I call an expanded frequency distribution. All right. Now, if you look back on the previous page where I had given kind of the important terms for this class, then you'll see that each one of these basically has a little formula. So like we'll start with the midpoint here. The midpoint is just the central value in each class. And so all you have to do to find that value that's at center is add the limits together and then divide that by 2. So for example, in class number 1, my limits are 35 and 41. So if I add those together and divide that by 2, 35 plus 41 would put me at 76. And if I divide that by 2, I'm going to get a midpoint of 38. And that's the value that falls right in between, halfway in between 35 and 41. And I can do that same thing for each class. So for 42 to 48, if I add those limits together, 42 and 48, that's going to put me at 90. Divide by 2. And I get my second midpoint, the central value, at 45. Now, you can continue using this formula, or you can notice here that the difference between the midpoints is 7 again. That class width is going to follow you through. Anytime you're looking at one class to the next, it should show you that class width. So a shortcut is once I've found one, I can just start adding the class width, right? From 38, I go to 45. Add 7, this next midpoint will be 52. Add 7, I'll be at 59, 66, and 73. And notice these are the values that are halfway in between the lower and the upper limit for each class. All right, now we'll come back to those. We're going to use those when we start graphing in just a few minutes. But let's go ahead while we're here and let's talk about the 2 different ways to talk about the frequency in each class. Now, my relative frequency, all right here, is basically just the percentage of values in each class. It is usually denoted as a decimal, round to 2 decimal places. But notice all I have to do to figure that out is take the frequency of the class and divide by the total. So if I come back over here to my data set, there's 2 ways to determine the total frequency. One is just to look at how many total data values you have. The other, if you don't have the data set sitting in front of you, is just to look at your frequency column and add them up. All right, notice either way, I'm talking about a total frequency of 30. So if I go to class number 1, the frequency here was 12 speeds. So I'm going to take the 12 speeds, I'm going to divide them by the total frequency, and that's going to give me a relative frequency, and I usually round these to 2 decimal places if needed. Sometimes my stat lab will ask you to round to 3 decimal places, so just watch that. But this is a relative frequency of 0.4, or a percentage, if you want to look at it that way. 40% of the values fall between 35 and 41. And again, this formula goes the same for every class. So class number 2 has a frequency of 11. Divide that by the total frequency. Now I'm getting 0.36 repeating. So round this to 2 or 3 decimal places, depending on how my stat lab asks you to round it. And it has a relative frequency of 0.37, or a percentage of 37% of the data. And I'm going to follow that through. So my next class has a frequency of 4. Divide that by the total frequency to get the relative frequency at 0.13. And then the same thing for these last 3 classes, which each have a frequency of 1. They will have a relative frequency of 0.03. And you should always notice if you add up your relative frequencies, they should sum to 1 or very close to 1, depending on rounding. If that doesn't happen, then that's a kind of an easy way to catch that maybe you made a mistake in there. All right, so frequency, how many are in each class, relative frequency, what percent or what portion, decimal-wise, are in each class, and then cumulative is like a running tally. So right here at our cumulative frequency, basically we're adding up. We take the sum of what happens in the class and we add in the frequency for all classes that came before the class you're on. Okay, so for the first class, there will be no change from frequency to cumulative. Nothing happened before the first class. So if the frequency is 12, then the cumulative frequency is 12 too. But when you get to your second class, you got to start adding together. So for my second class, the frequency is 11, all right? See that right here. But the class that came before it had a frequency of 12. So I'm going to add those together, and I'm going to report a cumulative frequency of 23, because that's the sum for what happened in this class and the class that came before. All right, now let's do one more here to make sure we're seeing this correctly. For the third class, right, the frequency of the class is 4. But I've got to add in the frequencies that came before, all of the frequencies that came before. So I'm going to add in the 11 and I'm going to add in the 12. But notice this is basically just like taking that 4 and piling it in there with the 23, because when I add these together, I'm going to get a cumulative frequency of 27. So really, basically what you're doing is taking the cumulative frequency that came before and just adding in that class. So like if this has a frequency of 1, that'll put this at 28, then 29, and your last cumulative frequency should always be the same thing as the total frequency. All right, now you're probably noticing that as of right now, I have not talked about class boundaries. That's because those come in on the graphs. And so I'm going to hold off on those for just a minute. What I would like for you to do now, before you try to finish out the information in this section, is I would like for you to go to your practice problems, and I would like for you to look specifically at numbers 3, 5, and 11. All right, so remember, the way these things work, when you go to Chapter 2, just click on the Chapter 2 tab, Section 2.1, remember the Learn up there at the top, that is where you can find the textbook and the textbook videos, and that's what I kind of pointed you guys to this morning before I was able to make my video. Underneath that is where you can print the outline of the notes. And then in step number 2, that is your practice, right? So we're going to go into practice now in section 2.1. All right, you're going to come back and work through all of these, but right now I want you to look specifically at number 3. Make sure you're understanding how to use the class width formula and how to get lower and upper limits. Now, just a note here, basically what you're going to be doing is the first step that we did here. Calculate the class width and figure out your classes. But be careful in how this is asking for your answer, because you got to remember lower limits are all these values right here on the left-hand side. And it's going to ask you to put in all your lower limits first. Then upper limits, those are the values up here. And you're going to be asked to put those in separately. So just pay close attention to the instructions and how that is worded to make sure that you're putting the answers in the correct format. All right. Once you're doing okay with that, and remember, practice, you can work these as many times as you need to. Then I want you to go to problem 5, and I want you to practice the midpoint formula, the relative frequency formula, and the cumulative frequency formula. And once you're doing okay with that, then I want you to go and start question number 11. Now, all I want you to do is this first part. Make sure you can get the classes and the frequency, just like we did in our example. All right? And then once you've done that, I want you to come back and watch my second video, where I'm going to walk through the histogram with you, and you'll be able to come back and complete this problem at that point.